Now that you've watched the introduction to systems of equations with 3 variables, we're just going to knock out 6 problems here. I'm going to take you step by step through each one of those. So let's take a look at our first one here. It looks like this. And so notice, once again, we've got 3 lines, and this one's already solved for us. So this is going to probably make it our easiest problem of the day, because all we got to do is figure out, now that we know what z is equal to, we can substitute it back in to that second equation there. And I'm going to get y plus 2 times 8 is equal to 6. And so y plus 16 equals 6, or y is equal to negative 10. And that gives me my value for y. Then I can go back to equation 1 up here at the top, and I can solve for x. So I get 2x minus a negative 10 plus 5 times 8 is equal to 24. 5 times 8 is 40. And then this minus a negative 10 becomes plus a positive 10. And then 10 plus 40 is 50. Subtracting 50 from both sides, I get negative 26 equals 2x, or x equals negative 13. So this gives me my value for x. And then we're going to write this as an ordered triplet. So our final answer here, remember, it's going to be in the format of x comma y comma z. And so we get negative 13, negative 10, and positive 8. Negative 13, negative 10, and positive 8. All right, let's take a look at the next one. Next one's very similar to that. I've already got z solved for you once again, but you give it a try now that you saw that one. If I can hold it still for you there. There you go. Pause the video, give that a try. All right, I take it that you've taken that chance to pause it. You gave it your best shot. Let's see if you got it right. So I already got z solved for. And then I'm going to say, okay, if I put 2 in for z into equation 2 there, I get y plus 2 equals 12, or y is equal to 10. So that solves the equation for y. And then I'm going to go back to equation 1 and put both of those into it. So I get 2 times x plus 10 minus 3 times 2 equals 10. Negative 3 times 2 is negative 6. And 10 minus 6 is 4. Subtracting 4 from both sides, I get 6 equals 2x, or x is equal to 3. And so I'm going to write this as an ordered triplet. And you get 3, 10, 2. Not too bad on that one either. They get more difficult, though, as z is not solved for. So don't leave me just yet. Let's try out one of the harder ones. So maybe you watched my other video. If you're in my class, you should have watched my other video. And so you're ready to tackle this one. Pause the video, give it a try. All right, in the other video, what we talked about was actually numbering these equations, because it makes the communication and the organization of these problems so much better just by numbering them 1, 2, and 3. And what we're going to do is come up with an equation 4 and sometimes even an equation 5 that are in 2 variables that we can solve. Now I notice that equation 3 on this only has 2 variables. The y's already gone. So I'm going to use that to save me some work. So I'm going to go to equation 1 and 2 and say, well, let's get rid of the y there. And then I'll have equation 3 and a 4th equation that I can pair up. So when I'm looking at equation 1 and 2, I notice that equation 1 has a coefficient of positive 1 in front of the y, and equation 2 has a coefficient of negative 1. So if I add up these two, the y's will cancel, and that's exactly what I'm going to do. I'm going to say equation 1 plus equation 2, and that's going to give me equation 4 here, the 4th equation. Not 1 plus 2 equals 4, that's not what I'm saying. Remember, the equations are numbered. Equation 1 plus equation 2 equals equation 4. And so if you want, we can write it out. Usually I'll skip that step, but because we're learning, I'm going to write it out. X plus y plus z equals 7. And then 2x minus y plus z equals 9. A lot of times I just add them up right here and just write it down, just so you can see them lined up one above the other. I wrote it out. X plus 2x is 3x, y minus y is 0, z plus z is 2z, and 7 plus 9 is 16. This gives me equation 4, and the y has been eliminated in it. Equation 3 already had the y gone from it, so now what I'm going to do is pair up equation 3 and equation 4 and use elimination to eliminate either x or z. I get to pick. Now I notice that this equation 4 has 3 as a coefficient, so does equation 3. So if I just multiply equation 3 by -1, when I add it to equation 4, the x's will cancel. So that's exactly what I'm going to do. Right here, I'm going to say equation 3 times a -1. I'm just kind of writing out right here what I'm doing, so we can kind of keep up with that. So as I write it down, let's go ahead and do that. Let's write out -1 times 3 gives me -3x. -1 times -z gives me +z. And -1 times 10 gives me -10. So when I add these, the -3 and 3 will cancel out. 2z plus z is 3z. And 16 minus 10 equals 6. Divide both sides by 3, I get z is equal to 2. So there's one answer right there. But I need to figure out what x and y are as well. Well, looking back at equation 3, the y's already gone out of it. So I'm going to take and plug this z into equation 3 to figure out my x. So let's do that next. So we get 3x minus 2, that's z's value, is equal to 10. So 3x equals 12, or x is equal to 4. Now that I know z and x, I can substitute it back into, say, equation 1 and figure out what my y value is. So substituting in equation 1 gives me 4 plus y plus 2 equals 7. 4 plus 2 is 6, so if I subtract 6 from both sides, I get y equals 1. Now let's not leave it like this. Let's write it out as an ordered triplet. So the ordered triplet goes x, y, z, so it's going to be 4, 1, and 2. And there's our answer. All right. That one's a little bit more work to it. And I think that's the hardest thing about these things is that they're tedious. You have to be careful and you have to be organized. That's why I'm saying as we do this, number your equations so you don't make mistakes. Be very neat. I know a lot of you, when you turn in your quizzes and your tests, your work's everywhere. You even tell me, like, you come up and you're like, here's my test, here's my work. It's a little bit, my work is a mess. It's everywhere. Don't be like that. I'm the same way. I'm not a very organized guy, but on this stuff, I have to be very careful or I will end up making a mistake. So you do the same thing. Number your equations and be organized as you do this work. Go ahead and pause the video and give this one a try. All right, I take it that you were organized, you gave it your best shot. Let's see if you got it right. So looking at this, once again, we are going to number our equations 1, 2, and 3, and be very careful with this because there's 2x, 2z, 5x, 3y, 3y, 4z. They're all missing one of those variables, and you notice that z's are listed with the y here, and the x's are listed with the y right here. So be careful when you add these up or when you're choosing which ones to eliminate that you don't assume that, this is an x when it's not, because that can be easy to do sometimes. Now, there's no one correct way to start this off. You could choose to eliminate the y, z, or x. I'm going to look at this and say, let's eliminate the z's. So looking at it, I say, you know what? If I pair up equation 1 and 3 here, and choose to multiply equation 1 by 2, so 2 times equation 1, and write it down right here, I can add it up to equation 3 and eliminate the z's. So 2 times 2x is 4x, 2 times 2z is 4z, and 2 times 2 is 4. And I'm going to add this to equation 3. 4 plus 4 is 8. Negative 4z plus 4z is 0z's, so it just kind of cancels each other out. And then 3y plus 4x I can't add. It has to be written out like this, 3y plus 4x. See what I'm saying? Be careful, don't add those two up. They're not common, they're not like terms. This gives me equation 4. Let's write that down. That's equation 4. And now I want to pair this up with equation 2. Why? Because equation 2 has just x and y in it, just like equation 4 does. And so looking at this, I can eliminate y very easily here just by multiplying equation 2 by -1. So that's what I'm going to do. I'm going to say -1 times equation 2 and write it down right here. And so -1 times 5x is going to give me -5x. Notice I'm writing it down right underneath its like term. And -1 times 3y gives me -3y. And then -1 times 4 is -4. Add those up. The y's will cancel, and I get -x is equal to +4, or x equals -4. That's one variable solved for. Let's go back and put it into, say, equation number 1 and solve for z. So 2 times -4 plus 2z equals 2. This is -8. Add 8 to both sides, I get 2z equals 10, or z is equal to 5. There's my second variable. I'm going to put this into equation 3 and solve for y. Draw a line there if your work needs to not run into something else. So 3y minus 4 times 5 equals 4. This is 3y minus 20 equals 4. Or 3y equals 24, y equals 8. And so what we end up with is, let's write it out as an ordered triplet. The x comes first, and then the y, and then the z in alphabetical order there. -4, 8, and 5. All right, let's try looking at another one like it. Let's look at number 5 here. Pause the video and give this one a try. All right, I take it that you paused it, you gave it a try. Let's number our equations 1, 2, and 3. And so looking at this, let's see. I got an x and a y, an x and a z, and a y and a z. I'm just going to choose to eliminate, let's see, what's a nice easy one? So x, 2, and 3. The z, you got 3 and 4. The y's, you got 6 and 3. I think it's easier to eliminate the y's first, just because 6 is a multiple of 3. You could pick another one if you wanted to, but I'm not. So I'm going to take -1 and times it by equation 2. And write that here. That gives me, let's see, -1 times, no, not -1. I want to multiply it by -2, don't I? All right, now let's try that out. So what that gives me is -6x minus 6y, and then equals -18. So that is -2 times equation 2. Below it, I'm just going to write out equation 1. So I'm going to write that down below it. And this gives me 6y. I'm going to write it underneath its like term, plus 4z. Just keep in mind that these two are not like terms. You can't really add those. And then -12. So adding these up, I'm going to get -6x plus 4z. These cancel. And then this equals -30. This is equation 4. Now looking at this, I also have equation 3 that has just an x and a z in it. So I'm going to pair these two equations up. I'm going to choose to eliminate the x's though. To eliminate the x's, I need to make this +6. And to do that, I'm going to multiply it by 3. So it's going to be equation 3 times the number 3. And that gives me 6x minus 9z is equal to 30. And I'm going to add these up. These will cancel. This gives me -5z equals 0, or z is equal to 0. So there's my first variable solved for. Putting this back into equation 1, I can figure out y's value. 6y plus 4 times 0 equals -12. So 6y equals -12, or y equals -2. There's my second variable solved for. And then lastly, I've got y and z. I can solve now for x. I'm going to put this into equation 2. And so putting in y there, I get 3x plus 3 times -2 equals 9. So negative 6 here and 3x right there. Add 6 to both sides. I get 15 equals 3x, or x equals 5. And putting this into an ordered triplet, I get 5, negative 2, 0 as my final answer. All right, let's look at one more here today. There you are. Pause the video and give that one a try. All right, I take it you gave it your best shot. Let's label these 1, 2, and 3. And looking at this, let's go ahead and start off by, I don't know, I'm just going to eliminate the x's. So I'm going to use equation 1, write it out. And then I'm going to say negative 2 times equation 2, and write that out. So equation 1 is 2x plus y minus z equals 7. And then multiplying everything here by negative 2 gives me negative 2x plus 4y minus 4z equals 18. I'm going to add those. Adding these up, I get those cancel. Y plus 4y is 5y. Negative z minus 4z is negative 5z. And 7 plus 18 equals 25. This is equation 4. That's a new equation. I'm just going to make it green this time just to go something different. Now, looking up here, they all have all three variables in it. I used equation 1 and 2. I need to get equation 3 involved. Otherwise, it doesn't really do me much good. I want to know when do all three of these intersect. So I'm going to use equation 3, and I want to eliminate x still. So I'm going to write down equation 3 right here. And I'm going to use equation 2 because it has a coefficient of 1. I'm going to multiply it by negative 3. So negative 3 times equation 2 will give me something that when I add these up, it eliminates the x's there also. So writing out equation 3 gives me 3x minus y plus z equals 5. And then taking negative 3 times equation 2 is going to give me negative 3x plus 6y minus 6z is equal to 27. And I want to add those two equations up. Those cancel again. I get 5y minus 5z equals, let's see here, 5 plus 27 is 32. This is equation 5. Now, the goal here was to take all three equations, get all three of those original ones together, and eliminate one of the variables, which I've done. I've eliminated the x. I've come up with two new equations, 4 and 5, and neither one has an x in it. So I'm going to use equation 4 and 5, just like we did it in the last section where we had a system in two variables, which I have here, y and z, just two variables. And I'm going to solve for one of these variables by elimination or substitution. So when I look at this, I say, you know what? I can eliminate the y by multiplying equation 4 by negative 1. So that's what I'm going to do. Negative 1 times 4, not times 4, but equation 4, gives me negative 5y plus 5z equals negative 25. And I'm going to add those. 5y minus 5y cancels. Just what I wanted. Now let's solve for z. Negative 5 plus 5, though, gives me 0z, or 0, and negative 25 plus 32 equals 7. That's not a true statement. So once again, we got it where both variables were eliminated, and we end up with something that's a non-true statement, which means there's no solution. Once again, I get students that get all upset. They say, oh, I did all that work and there wasn't a solution, and they get upset. But don't be upset. No solution is your answer. If you've done it like that, you've done it correctly, and you still get credit for it. So it's not all a bunch of work for nothing. You're still getting the right answer, okay? I hope those 6 examples gave you some extra help and maybe answered some of your questions. I'm more than happy to go through more problems. If you want to see them done, just let me know. Thank you for working hard. Thanks for watching, and I hope you're having a great day.